Hi everybody. So we have a new topic, a new very long section here that we're going to break into three parts, but it's all really about solving trigonometric equations. That is, solving equations with we're solving for a variable, but the variable is somehow related to a trig function. So there's no one-size-fits-all thing to go on here, but the main idea is, if you remember how you solved exponential equations, okay, when a lot of times you would solve, a lot of times if you had something like, something involving e to the x, if you first found what e to the x was, and then you could take the log of both sides, and and then you get x would be, the natural log of m. Okay. Another time, if you knew that log of x was, let's say, equal to 3, you could just raise e to the ln of x, and you get e cubed. So what we're going to be looking at is, if we have a trig function like sine of x equals some number, let's say m, then we're going to say, okay, if we can find out what the value of cosine of x is, or sine x, or tangent x, or some other trigonometric function equals a value, then we're going to look at the ways to solve that, solve what x is. Okay. So in this first set of problems, we're going to, some of them we've seen before, and I'm just going to be reviewing how to find all the solutions. And so basically, in this video, we're going to be looking at the basic problems, the basic trig functions, and these are the problems that you really want. When we get into bigger problems or more complicated problems, the strategy is going to be reducing those problems to one of these problems, when we just have a trigonometric function equaling some number. Okay, so let's just look at some of these examples. So sine x equals square root 3 over 2. Okay, so you ask, well, what angle as sine equals to square root 3 over 2? Well, if you're not quite sure, if you haven't memorized your unit circle yet, so the square root 3 over 2, we want the y-coordinate, points on the circle where the y-coordinate is root 3 over 2. So that would be something over here and over here. And you can remember, if you remember, 60 degrees, the sine of 60 degrees is equal to this angle, but everything is in radians, so this is pi over 3. Okay. And because this angle and this angle are the same, this angle should also be pi over 3. So that this angle from here to here would be 2 pi over 3. Okay? Or if you can think about this, you can just say, since this is pi over 3 as well, then here's pi radians, subtract pi over 3, and get 2 pi over 3. So basically, x equals pi over 3 is a solution, and also x equals 2 pi over 3 would be a solution. And then because the period has, the period of sine is 2 pi, we can add any multiple of 2 pi on to either of these numbers, and we'll still get a solution. And in this case, k is always going to be an integer, so that means k is going to be 0, plus or minus 1, plus or minus 2, and so on. I'm only going to write this once, but when you see the k, what we're saying is k can be any integer, okay, into this. Right. So, for a few solutions, of course, we'll have pi over 3 and 2 pi over 3 when k is 0. When k is 1, we get 7 pi over 3 and 8 pi over 3 and so on. Okay, and we can have as many solutions as we want. Okay. Let's look at example 2. Square root of cosine of x equaling the square root of 2 over 2. Again, if you haven't memorized this, okay, well, first of all, you might want to do that, but here we want the points on the circle where the x-coordinate is square root 2 over 2, and that's here and here about, get two angles. And in fact, if you memorize this, it's a 45-degree angle, or pi over 4. And of course, then this angle would be minus pi over 4. Okay. And remember, the cosine is an even function, so the cosine of x and cosine minus x are the same. So basically, you can just change the sign of x and you'll get another solution. So here we can see that x is going to be pi over 4 plus 2 pi k or x could be minus pi over 4 plus 2 pi k. Okay, this corresponds to this point, this corresponds to this point. Okay, where again k is just any integer. Alright, so we want, let's say we could get pi over 4. We want the first few positive solutions. Negative pi over 4 plus 2 pi times 1 when k equals 1. This would be 7 pi over 4. Okay, and so on. The next one would be 9 pi over 4. The next one would be 15 pi over 4, and so on. Okay, so that would be those solutions there. When cosine x equals -1, that is, I think if we recall, when this cosine is -1, in this case there's only one point on the unit circle where the where we have the x coordinate is -1, right? That's right here. That corresponds to pi. Okay, so x is going to be pi plus 2 pi k. Okay. And then you could also write minus pi plus 2 pi k, but that would sort of be included in here, right? Because there's basically the number of points on the circle correspond to the number of solutions, sets of solutions you have here. So you could have, you know, when k equals 0, you get pi, or 3 pi, or 5 pi, and so on. You would also get, of course, negative pi and negative, that k is -1, you get negative pi, and then negative 3 pi, and negative 5 pi, and so on. Okay, but these are all fall under this form. When the tangent of x is the square root of 3, it might be helpful to realize that this can be also be written as a square root of 3 over 2 divided by 1 over 2. So you might want to ask yourself, since this is the what angle has sine square root 3 over 2 and cosine 1/2? Well, actually it's the same angle over here, pi over 3, right? So we can say x is going to be pi over 3. But we don't have 2 pi k, because what's the period? Remember, the period is pi. Okay, remember that from looking at the graphs and so on. So it's going to be, we can add any multiple of pi onto this. Okay, and that's going to be the only solution from negative pi over 2 to pi, and that's it. Because if we look at the graph, remember, if we look at the graph of tangent x, okay, it's just from here to here, it's strictly increasing. So if you draw a line here at pi over 3, or rather at square root 3, you're going to get one intersection, one point of intersection. So these are all the solutions. So you get pi over 3, you're going to add pi, and you get 4 pi over 3, and 7 pi over 3, and so on. Of course, you get also negative pi over 3, and so on, like that. Okay, actually, not negative pi over 3. It would be negative 2 pi over 3. Sorry. Okay, so on. Okay. When k equals -1. Okay. So there's some solutions there. All right, secant of x. When is the secant of x equaling 2, or -2? Well, secant x, we can just is easier if we just write everything in terms of one of the either cosine, sine, or tangent. And we know this is the reciprocal of cosine, so this means the cosine of x is -1/2. Okay, so you ask yourself, okay, well, which angles have cosine equal -1/2? Okay, that's the points on the unit circle where the x-coordinate is -1/2. And we can see, if we remember from here to here, 2 pi over 3 is one of the examples. And also negative 2 pi over 3. This would be the other angle that corresponds to this point. So x would be 2 pi over 3 plus 2 pi k. We're back to writing 2 pi because we're back to a trig function whose period is 2 pi. And then x equals -2 pi over 3 plus 2 pi k. So we get values like 2 pi over 3 4 pi, if we add 2 pi to this, we get negative 2 pi over 3 plus 6 pi over 3, so that would be 4 pi over 3. Okay. And then if we go, the next solution would be, if we let k equal 1 here, we would get 8 pi over 3, and so on. So figure out what these other other ones are. All right. Look at the next one. Okay, if I can find out where I put this, here it is. Sheet. So cosecant of x, you want cosecant of x to be the square root of 2. This means that the sine x, because that's the reciprocal of this, that's equal to 1 over square root 2. Or if we rationalize it, this is equal to the square root of 2 over 2. And we should recognize that that is pi over 4 and negative pi over 4, because we have, we're down here, actually. So, sorry, we're up here. So it'd be, actually this would be pi over 4. And then the other one would be over here. So this is pi over 4. This angle is also pi over 4. So the angle from here to here would be 3 pi over 4. Okay. But you could also write this as negative pi over 4. I think. Why did we do that? No, we can't do that. Okay. So that is, I was right. I was wrong in my notes, but I'm right now. Okay, great. So x is going to be pi over 4 plus 2 pi k, and x would be, the other solution would be 3 pi over 4 plus 2 pi k. Okay, where again k is an integer. Okay. So you can have, you can see it would be pi over 4, 3 pi over 4, and k equals 1. We get 9 pi over 4, and then 11 pi over 4, and so on. Okay, these are a few solutions. Cotangent is the reciprocal of tangent, so this means the tangent of x is 1 over square root 3. Okay. And again, this is going to, you really just have to sort of memorize these values especially for tangent. You could write this as 1/2 over 1 over square root 3. And the angle whose sine is 1/2 and whose, I'm sorry, this should be root 3 over 2. So the angle whose sine is 1/2 and the cosine is square root 3 over 2 is pi over 6, right? So this is just going to be x equals pi over 6 plus pi k. I'm going to use the pi k again because this is tangent and the tangent has period pi. Okay. Let me answer the phone and I'll be right back. All right, thank you. I'm back. Stupid, do not call list. All right. Now, these last 3 examples have to do, or 3 or 4 examples have to do with, you need a calculator, kind of a calculator to do this. Because in general, you won't, in these first few examples, the numbers here were specially chosen so we could just sort of use our unit circle or use our memorized values. But there's no angle that we've talked about on the unit circle whose sine of x is equal to 0.7. So that means we have to go and just use our calculator. Okay, so we won't make sure our thing is in radians mode. We can take the inverse sine of both sides. And so x is going to be, one of the solutions would be the inverse sine of 0.7. Okay. Now there's also another set of solutions. So, so obviously let me just say that this would be, one set of solutions would be the inverse sine of 0.7 plus 2 pi k. All right. But remember, for the for other cases where we had when we're doing the sine, there were two solutions, one in the first quadrant. Okay, in this case, if it was, this would be the first quadrant because x is 0.7. So, just do this. If we look at our unit circle, so here's 0.7. So we'll have a point here and a point here. So we have an angle in the first quadrant and an angle in the second quadrant that works. So this first angle in the first quadrant is the inverse sine of 0.7. The second one is going to be pi minus this. Pi minus this, whatever this angle is. Because this angle and this angle are the same. So x could be also equal to be pi minus the inverse sine of 0.7 plus 2 pi k. Right. And to do this, you make sure that you're in radians mode. This turns out to be 0.775 on your calculator, and this number turns out to be 2.366. Okay. Okay. So just again, make sure you're in radians mode when you do this. The inverse cosine of negative 0.43. This is another case where we have to use our calculator and our inverse cosines. Take the inverse cosine of both sides. And then this is x. If x is in the first quadrant, then x is going to be the inverse cosine of negative 0.43. Actually, in this case, x would be in the second quadrant because this is a negative value. All right, so again here, so this would be, so here's negative 0.43. And then these are two angles, one in the second quadrant, one in the third quadrant. And because it's cosine, then it's just going to be the other set of solutions is going to be the opposite of this. So x will be the inverse cosine of negative 0.43 plus 2 pi k. And the other set of solutions will be given by minus inverse cosine of negative 0.43 plus 2 pi k. Now on your calculator, this value turns out to be 2.015, and of course then this will be negative 2.015. All right, so you can go ahead and plug in some values here. If you want to find the first two positive values, this would be the first one, and then it would be this number plus 2 pi. So the first two positive values would be 2.015, and then the next one would be 4.268. Okay, that's this number plus 2 pi. Okay, so there's some others. Again, make sure you are in radians mode. We're not going to mess with degrees, at least not yet. Okay, tangent. Tangent, we have the tangent is 1.65. Well, it looks like x will have to be the inverse tangent of 1.65. Okay, so this would be, so x would be the inverse tangent of 1.65 plus pi k. And this, if you use your calculator, this is going to be 1.26. Okay. All right, and then if you let pi, so that would be one solution, and if you can keep adding any multiple of pi you want, and you'll get another solution. And then finally, if the cosecant of x is going to be 3 halves, this means that the sine of x is going to be 2/3. Okay, so you can see that x is going to be the inverse sine of 2/3, so will be one solution. Okay, and then again we would have the other solution would be pi minus the inverse sine of 2/3 plus 2 pi k. where again the inverse, on the calculator, this inverse sine of 2/3 is 7.730, and this number turns out to be what does it turn out to be? I have 2. I have one number. I'm not sure which one it corresponds to. You can just calculate it right now. So we have pi minus the inverse sine of 2/3. Okay, it's 2. Oops, I missed. Try again. Mistyped something. Yeah. Okay, I was right the first time. So this is 2.412. Okay. I kept you in suspense there. All right. So, and of course, you could actually have done this with the first few problems too. Okay, you could have said, for example, you could have done this with taking the inverse sine of square root 3/2. Okay, but it would be it would give you a decimal approximation for pi over 3. So you still have to know that pi over 3 is the exact solution. So because on some of the homework they're going to ask you for the exact solution, not the decimal approximations. Okay, if you have a problem like this where you have the sine of x is equal to one of the known values from the unit circle. All right. Practice. These are the basic problems. You want to make sure that you can do these problems first before you go on to the next video. Okay? Take care, and I'll see you next time.